let us become a detective, a chemistry detective. Okay, so I and you all are going to behave as a detective. As you know that the detectives, they do what? They trace the fingerprint of the culprit and they find out that the person who has done any crime. Same way, we will also try to find out the fingerprint of various elements. Okay, so actually, as the fingerprints are specific for specific persons, okay, that is absolutely a unique thing that not a single individual will have the same type of a fingerprint. So every individual have different fingerprints. Similarly, the elements, they also have fingerprints which are actually unique for them. So if you see the helium, lithium, sodium, so they have different type of the fingerprints. So in this way, where the helium is hiding behind and where is the lithium and where is the hydrogen, so that we will be able to find out. Okay, so that is today's task. So let us behave as a detective today and find out that what is element's fingerprint that comes under the atomic spectra. Okay, so first of all, you have to know that what is a spectroscopy, because this comes under the branch of the spectroscopy. So the study of interaction of the matter with electromagnetic radiation is known as spectroscopy. So electromagnetic radiation, one of the simplest example is the light radiation which is coming from the sun. So you know that it falls on various matters and which produces a specific color band that comes under the spectroscopy. So the energy, whenever this light radiation they fall on any matter, okay, so certain amount of the energy, this light radiation is either absorbed or emitted by the matter, and that is in the form of the quanta. Now, this absorption and emission through a range of electromagnetic spectra is produces this particular bands, and they are known as the spectrum. They are known as the spectrum. So I'm just giving you a rough idea of this. Now you know that when the star or any sun, its light passes through the prism, it produces various color bands, and this is known as the spectra. And this is actually an example of continuous spectrum. You can see that the one color band is merging into the one another, so there is a no demarcated boundary. So the orange color, it is getting mixed with the yellow is getting converted up into the green, and then this way. So this is known as continuous spectra. So this type of the color band produces. Okay, so atomic spectra. So I will talk about the fingerprint as we were talking. So when an atom get excited, so how the atom get excited? So when any light radiation falls on an atom, so the electrons which are present in the outermost orbit, they get excited to the next higher energy level. After some time, they come back to their original level again. So when they come back to their original level again, they emit certain light radiation. Okay, that we can see in the form of the different colors. The emitted light can be observed as a series of colored lines with dark spaces in between them. This series of the colored lines are known as line or atomic spectra. Each element produces a unique set of spectral line. Since no two elements emit the same spectral line, the elements can be identified by their own spectrum. They are unique, and they are unique to each element. As you know, the fingerprint is unique. You have your own fingerprint. Your fingerprint will not match with your any of the friend. Similarly, for example, the hydrogen or the oxygen, they are going to produce a specific line spectra, which is known as atomic spectra. So hydrogen's line spectra will not match with the oxygen's atomic spectra or the line spectra. So that is unique for the hydrogen, and the hydrogen's oxygen's atomic spectra or line spectra, that is unique for the oxygen only. So in this way, we can demarcate the hydrogen from the oxygen and from the chlorine, and in this way all the elements in the periodic table, they have their own line spectra. Okay, so I have just given you a rough idea of this, and actually you have to understand emission spectra, absorption spectra. This line spectra comes under the emission spectra actually. So if you want to know the detail of this, you can join us. Thank you and have a nice day, all of you.